Morning. Hi, everybody. This is going to serve as our going over the test portion of things. If you are needing a retest, then that will be handled on Friday during class. Is that right? No, we don't have class on Friday. Then that means that will be handled on Thursday during class. Here we are when bromine water is shaken in sunlight. That thing where it says it has to be shaken and it has to happen in sunlight should be your cue that it needed just a little bit of activation energy and it just didn't happen naturally as would an alkene. So the correct answer here is that this is an alkane because it needed sunlight and it needed some shaking. Okay, so the next one, identify the structure of the repeating unit of polybutene. All right, so the polymer here. So we have to be able to identify, well, what is the repeating unit? And so we should have drawn something that looked like this, and it should have had these two right here in the middle of it like this. And then it should have had a methyl group hanging down here. And it should have had a methyl group hanging down here. And then it should have, sorry everybody, bad handwriting, and then it should have had this here and an N. And I'm going to be really flexible with how you showed this, but you did need to show that the parts that were hanging outside the parentheses, the N was required, all of those things. So we'll take a look at that. I tried to do it on my own writing, and as you can see, it was less than optimal. So there we go. All right, moving on to our next solution here. Describe a chemical test that could be used to distinguish between pent-1-ene and pentane. And so here we're going to be putting both in bromine water, or Br2, and then being able to describe the fact that pent-1-ene would decolorize while pentane would not decolorize due to saturation in pent-1-ene and no or really unsaturated in pentane. Okay, so our next question. Which of the following statements about alkenes is not correct? The correct answer of the not correct is they react mainly by substitution. No, that was alkanes. Alkenes react mainly by addition. So this correct answer, most people got that one right. Which statement is correct about the polymerization of ethene to polyethene? The monomer ethene and the repeating unit have the same empirical formula. Yes, because all you're doing is breaking a pi bond so that there are places for connections to be made. You are not changing the mass by adding even a hydrogen to it. The polymer contains single bond Cs and double bond Cs. Yes, sort of, but usually the double bond has been broken. If there's more than one double bond, there might be a double bond. But in this case, there was only one double bond. The polymer is an alkene. No, the polymer is not an alkene. It has had its double bond broken. And the monomer ethene is less reactive than the polymer. No, because of those pi bonded electrons, it is more reactive. Okay, so we go on. Butene can be formed from an electrophilic addition reaction. Name the reactants and the conditions. So you had to say butene is reactant 1, hydrogen, H2, is reactant 2, and the catalyst would have had to have been PT or platinum or nickel, and you could have also said heat, but it was really, I was just looking for platinum or nickel here. So but2ene, hydrogen, and platinum or nickel. Either one of those would have been correct answers there. Describe and explain the color change observed when excess but2ene reacts with bromine to form compound A. Here you were just describing that color change. So but2ene reacting with bromine would lead to decolorization, and that seems to be a common theme throughout this test. I didn't realize I did so many of those questions. This next one, write and balance the reaction, the complete combustion reaction of propene. What is the correct set of balance coefficients? You had to remember that you were using propene, so C3H6. plus O2 yields CO2 and water, and then being able to balance that correctly led us to 2966. If you have questions about balancing, we're going to have to do that in tutorial time. Consider the full structural drawings of propene and butene. Explain why the propene molecule does not have geometric isomers, but butene does, and what are the names of these two isomers. Okay, so the reason why propene does not have a geometric isomer is because propene has a double bond between carbon 1 and carbon 2, and that means carbon 1 has two hydrogens on it, and for there to be geometrical isomers, each carbon must have a different set of substituent groups on it. So with there being two hydrogens on carbon number 1, then that means that it can't make a geometrical isomer because the two hydrogens would just have no difference between them. So then what are the names of these two isomers? Butene would have two isomers. One of them would be cis butene or cis-2 butene, and the other one would be trans-2 butene. And so those are the two geometric isomers. Okay, state and explain the trend of the boiling point in the first 5 members of the alkene homologous series. You would have to say that the boiling point is increasing due to an increasing amount of surface area. And then include in your answer 2 features of a homologous series. A homologous series is only different, progressively different by the addition of a CH2 group, and it changes by an increasing or by a progressively changing set of physical properties. You could have said physical and chemical properties, and that would have been acceptable as well. Some reactions of butene are given below. Deduce the full structural formula of A and name it, but do not use capitals. So you are adding to compound A, you are adding Br2, so you should have come out with 2,3-dibromobutane. And most of us did that correctly. You did need to, I will be, of course, checking everybody's answers, so no worries there if you think you got something right that should be counted. What is the mechanism of the reaction between alkenes and halogens in the absence of light? That is called electrophilic addition. Remember, the breaking of the bond leads us to a heterolytic fission there, causing one side to be negative and one side to be positive, and it's that positive side that is attracted to the electrons, pulling the electrons in the pi bond away. But the correct answer was electrophilic addition. Okay, here is the schematic diagrams of the reactions of propene. Name compound A. So let's start with naming compound A. Compound A should have been propane, and then compound B should have been propanol or 1-propanol, or actually I would have said that compound B had to be 2-propanol because the OL needed to go in the center, so 2-propanol, and then compound C would have had to be 2-bromopropane, and then compound D would have had to have been 1,2-dibromopropane. Okay, so identify the compounds that would be most likely to form both a major and minor product. That would have been both B and C, and so B and C would have had to have been major product 2-propanol, minor product would have been 1-propanol or propanol. For compound C, it would have been 2-bromopropane or 1 or just bromopropane for the minor product. Okay, so then we go on to this question here. Draw the correct structure of compound C, name it, and explain that one. There is only one product that can form in this reaction. So compound C is made with the concentrated H2SO4 as your catalyst and the water here. Since compound C is formed from butene, and that is symmetrical, then the only one thing that can form is the CH3, and one of these is going to be a CH2 where the H goes on, and then the other one, doesn't matter which one, is going to be CH, and it will have the OH or the alcohol added onto it, and then the last part of this is going to be CH3, and that should have been what you drew. And it didn't matter which one you drew it on because it comes out the same. And the reason why only one possible product can form is because it has a symmetrical reactant, butyene. Okay, so our next example here, butyene is a straight chain alkene with the formula C4H8. The molecule contains both sigma and pi bonds. Explain the formation of the pi bond. You should have said side by side or parallel bonding in that second double bond. And then for carbon atoms, name the type of hybridization. So for C1, you should have said sp3. C2 and 3 should have been sp2, and C4 should have been sp3. So we're going to take a look at what everybody wrote. Don't worry, I will check it all out. Thank you, everybody. That is your test explanation.